We are about to mark the beginning of the day session on formulation and testing of hypothesis. I welcome you all to the second day of the 5 day national level webinar series on research methods and techniques organized by the Postgraduate Department of Commerce and Management, association with the Research Club and Internal Quality Assurance Cell of Risudori College of Management and Technology, Chengalpattu, in collaboration with the Indian Accounting Association, Alapura branch. Participants are requested to keep your mic muted for the smooth conduct of the program since we are going live in YouTube. Questions for the Q&A session can be posted in the box. And for any queries related to the feedback link and the issue of certificate, you are requested to contact the online secretary through the email ID that this will be provided to you in the chat box. Without much delay, let us begin today's program by invoking the blessings of God Almighty. Prayer is an expansion of total faith in the present power within and around us. I invite the department choir for the prayer.
अखण्डमण्डलाकारम् व्याप्तं येन चराचरम् तत्पदं दर्शितं येन तस्मै श्री गुरवे नमः। त्वमेव माता च पिता त्वमेव बन्धुश्च सखा त्वमेव विद्या द्रविणं त्वमेव सर्वं मम देवदेवा त्वमेव सर्वं मम देवदेवा त्वमेव सर्वं मम देवदेवा।
Let me now invite Ms. Renee Matthew, faculty of the Postgraduate Department of Commerce, for the official words of welcome.
It's a warm good evening to one and all. Dear and most honorable speaker of the day, Dr. S. Kevin, the former Pro-Vice Chancellor of Kerala University, respected Principal, Reverend Father Joshi Chirankuri CMI, our beloved Head of the Department of Commerce, and Vice Principal, Dr. Verghese Anthony, the former Head of the Department of Commerce, Dr. Matthew Emmanuel, Head of the Department of BBA, Dr. Professor Thomas Matthew, IQAC Coordinator, Dr. Anu Anthony, Dr. Anthony Joseph K., the President, Indian Accounting Association, Alapura branch, and Associate Professor, SB College, Changanasheri. Dr. Vinay Chandra, the Secretary, Indian Accounting Association, Alapura branch, and Assistant Professor, SD College, Alapura. Eminent scholars, academicians, and students. It's given me a great privilege to welcome all our delegates on the second day of 5-day national webinar series on research method and techniques in association with Indian Accounting Association. This webinar is built with an intent to active and interactive learning, especially on the topic is formulation and testing of hypothesis. Our keynote speaker of the day, Dr. S. Kevin, is completed more than 29 years of teaching experience at the University of Kerala. He published several articles in scholarly journals. He served as chairperson of NAC peer team for assessment and accreditation of colleges in different states. We are so privileged to have him as our speaker on this webinar series. On behalf of the entire team, we welcome you, sir. Thank you, sir. Our principal, Reverend Father Joshi Chirankuri CMI, the man behind the success of this institution. And his paternal care keep us motivated always. So we are proud of you and welcome you, Father. Our head of the department and vice principal, Dr. Borges Anthony, he always with us providing a necessary guidance to conduct webinar series. Thank you, sir. Welcome you, sir.
Thank you.
I also welcome former head of the Department of Commerce, Dr. Matthew Emmanuel, and head of the Department of BBA, Professor Thomas Matthew, and IQC coordinator, Dr. Anu Hani. Welcome you all. I feel delighted to welcome you, Dr. Anthony Joseph K. and Dr. Vineet Chandra to this session. I welcome all of you, but especially the participants to this session. Thank you all. Thank you very much.
Thank you, Ms. Rennie Matthew. Today, we are blessed to have an eminent personality as our resource person, Dr. S. Kevin, the former Pro Vice Chancellor of Kerala University, has over 29 years of teaching service in the University of Kerala as a lecturer, reader, and professor in the field of financial management, security analysis, international finance, research methodology, and many more. He has also served as the director of TKM Institute of Management Column for 3 years and as the director of Bishop Jerome Institute Column for about 5 years. As an approved research guide, he has guided several PhD and MPhil scholars and MBA students in their research activities. He has several research articles to his credit, published in reputed scholarly journals. He has also authored many books that stand relevant in the academia. Research Methodology for Social Sciences, published in 2019, is the latest of all his published books. With immense pleasure, I invite Dr. S. Kevin to enlighten us with the keynote lecture of the day. So please, the visual space is all yours now.
Good evening to all of you. I am delighted to have so many participants. I understand that there are a lot of people participating. It makes me apprehensive. So because I have to fulfill the expectations of all these participants. At the outset, let me thank Ms. Rennie Matthew for the words of welcome and Ms. Jeremy for the introduction. I will go straight into the topic. Am I audible?
Yes, sir.
Yes, sir, you're audible.
Okay, right. Okay, so our topic today is hypothesis formulation and testing. You are having a webinar on research methodology. And research is a difficult exercise. All of you will agree. I saw some people with doctorate also here already who have completed their research. So all of you will agree that research is a difficult and challenging exercise. It has many steps, many processes. You cannot complete it in 1 or 2 months, in 1 year, no. There are many, many stages, processes, sequential processes which have to be completed to complete your research work. First of all, you have to identify a very good economically, socially relevant topic. Then you have to do your literature survey and confirm that it is really relevant, useful to the society. Then you have to formulate your research plan, research design, the methodology part of it. Then you start with certain clear objectives for your study. And based on these objectives, you have to collect the data through a questionnaire. Preparing a questionnaire is a very difficult exercise. Again, collecting the data, true data, valid data requires a lot of time. And once you have collected the data, comes the last part of the data analysis before writing the thesis. The data analysis, you have to use a lot of statistical tools there. And there comes the hypothesis testing. During the data analysis, you have to do your hypothesis testing. And therefore, before that, you have to prepare based on your objectives, you have to prepare your hypothesis, you have to formulate your hypothesis, and the hypothesis have to be rightly formulated. Then only you can test it in the proper way, and you come to the conclusion whether the hypotheses are accepted or rejected. So all these processes are different processes, challenging processes, time-consuming processes. So each topic, each person deals with one aspect of it. In fact, I was talking to Dr. Anu yesterday. I have a lot of things to say to you, but within 1 hour or 1.5 hours, I will be able to say only the most important aspects. Some other time we will have the other things. Okay. So I will try to concentrate on what is a hypothesis, what is meant by, how do you formulate a hypothesis, and what is the meaning of testing a hypothesis. So that you have to understand. What do you say? We are all familiar with the word testing of hypothesis, but what does it exactly mean, testing a hypothesis? And then how do you do it? So these are some of the things. I will not go into the statistical application too much. I am not going into the calculations and so on, only the theory part. And therefore, these are things which I am trying to concentrate today. So with your permission, I will switch off my video and have a PowerPoint presentation so that you can follow it closely. Prepare your questions and doubts in your notebook. At the end of the session, you can ask me. And I will also share the PowerPoint with you, with the organizers, so that they can share it to you. So this is my plan. Yes, with your permission, I'm making the presentation. Hypothesis, formulation, and testing. Hypothesis is singular, SIS. It's a Greek word, therefore the plural is hypothesis, formulation, and testing. This is our topic of discussion today. Can you see the slide, one of you?
Yes, sir. Yes, sir.
Yes, sir.
It is visible.
Okay, thank you. Okay, so let us move straight away into the significance of the hypothesis, because sometimes people ask a doubt very often. Researchers ask a doubt. Should a research work, a PhD thesis, have hypothesis? Many students have a doubt. Should there be a hypothesis, or can you have a research study without hypothesis? Very genuine doubt. See, you can very well have a research study without hypothesis, without stating the hypothesis. But in every research study, a hypothesis will be implied there. So some hypothesis would be implied. Very often we state it explicitly, formulate it explicitly. Sometimes we do not do it. That's all. So hypotheses are there in a good research study. We are going to see how we can formulate it explicitly in a research study. And most of the research studies have hypotheses formulated very explicitly and also tested with the result of the test. Hypothesis formulation and testing are important procedures in empirical research. I mentioned about the research and the different processes. One of the important procedures or processes in the empirical research is hypothesis formulation first, and then after the data collection, hypothesis testing. Hypothesis also, the question is, why are hypotheses formulated? Hypotheses are formulated to guide the study in the right direction, because the study is very wide. Sometimes it may go in the wrong direction. You may not reach anywhere. It takes months and months and months. You are not reaching anywhere. So to reach the conclusion correctly, to finalize your study, to go in the right direction so that your objectives are fulfilled. It's hypotheses are formulated based on the objectives. So that when the hypotheses are formulated based on the objectives, so you have a clear road map to go. Where do you go? What is the kind of data that you collect? What is the type of test that you do? So you have a very clear guideline or roadmap for completing your thesis or research work. Hypotheses are tested after data collection. So we need data to test the hypothesis. So there again, see, the questionnaire that you do prepare to collect the data must be designed in such a way that you get the data required for hypothesis testing. So both these are connected. So you require data, we require quantitative data. That is why we use measuring scales in your questionnaire. So we want not yes or no questions and answers. So we want quantitative data so that it can be used for testing. So the questionnaire preparation time, we have to be careful that the data is collected in such a way that it can be used for statistical application as well as testing of hypothesis. And this hypothesis formulation and testing leads to the findings of this study. So your study, finally, we have some research questions. We want to find the answers to the questions. The answers to the questions come from the research hypothesis and their tested results. So our first topic is, what is it? Hypothesis. What exactly is a hypothesis? Many of you know this. I am just putting it in a simple way so that you will remember it correctly when you are doing your research work. So what is a hypothesis? Most of you know what is a hypothesis. It's a statement, simple statement, very simple statement to be tested for its validity. We do not know whether the statement is true or false. At the time of formulating the hypothesis, it is a statement, but we are not sure whether the statement is true or false. So it has to be, it may be true, it may be false. So we have to test it for its validity. It's a statement which may express the relationships between variables in a study. So in every study, there are many variables. By now, you are familiar with the word variable. So take any research study, what you are studying is different variables. So there may be a relationship between the variables that you use in your study. A simple example, advertisement expenditure and volume of sales. So the more you advertise, the higher the volume of sales likely to be. We do not know again. See, we are not sure. That is what we hope, what we expect. Logically, what we think that the more advertisement expenditure, the more the volume of sales. So there may be a relationship between these two variables. So we can express a statement, we can have a statement expressing the relationship between these two variables, but we have to test it and find out whether there is really a relationship between these two variables. Secondly, it may be a statement which postulates a difference between two groups in respect of some variable. See, in every study, we are studying people because it's a social science research. So we study people and their activities, their attitudes, their behaviors. So, and among these respondents, we call them technically respondents, the group we are studying. This group can, respondents, the people we are studying can be divided into different groups based on their gender, based on their education, based on their income, based on their residential status like urban, rural, etc. So the respondents can definitely be divided into different groups. So are there any difference between these groups in respect of some variable? Very important aspect to be studied in a research study. So your hypothesis may be expressing a difference between two groups in respect of some variable. I've given an example. The performance score of boys versus girls. In a class, there are boys and girls. So what is the score of the boys? What is the score of the girls? Is there any difference? Very interesting question. If there is a difference, then we go further and find out why the difference, who is having higher score. So many things come from, first of all, finding out whether there is a difference. Again, a hypothesis may be a statement which postulates the existence of a specific characteristic. So there are some characteristics in the people we are studying. For example, stress relating to job. We are studying bank employees or IT industry employees or government employees. So there may be a specific characteristic among them, stress relating to their job. That is a characteristic. So they may have stress, they may not have stress. We do not know. So in some industries, stress may be more. In some industries, stress may be less. Then we have to find out why and so on. So that existence of a specific characteristic in the group, in the people that we are studying, so we can express in the form of a statement that there exists stress or there does not exist stress and so on. So that again, we do not know, we have to test it and find out whether it is true or false. So these are three common, remember, these are three common types of hypothesis. It doesn't mean that there are no other ways of expressing hypothesis. There are many ways of expressing hypothesis, but these are the three common ways of expressing hypothesis. In higher studies, in some studies relating to econometrics and so on, the hypothesis may be expressed in a different way. So I'm just concentrating on the simple common ways of expressing a hypothesis, so that once you get used to this, then the other hypothesis types you can understand by yourself. Okay, so what is a hypothesis? We have seen. It is a statement which we do not know whether it is true or false, and this statement may express the relationship between variables, or it may express the difference between groups, or it may express the existence of a specific characteristic. Collectively, we can say that hypotheses are possible answers to the research questions or the anticipated outcome of the research. So we have some research questions, we have objectives, research questions. So the answer to those objectives and questions, the possible answers are the hypothesis. So once you test it and find out there exists a relationship or there does not exist a relationship, that is your answer or the outcome of your research. So that is why we say that hypotheses are important. They have to be correctly formulated, explicitly, and tested. Now, a definition of hypothesis, we have already seen what is a hypothesis. Logically conjectured relationships between two or more variables or differences between two or more groups expressed in the form of a testable statement. This is the textbook definition of a hypothesis. This is what I was trying to explain earlier. Or a statement proposing the existence of specific characteristics to be verified. Whether these characteristics are existing or not, we have to verify. So these are the formal textbook definitions of hypothesis. What you have to understand is the meaning of the hypothesis has to be clearly understood. Now, an important question then is, from where do you get this hypothesis? From where, when you are doing your research and you want to formulate a hypothesis, from where do you get this hypothesis? The most important source of the hypothesis is the related theory, because every study has a basis in some theory, because normally the study will be related to some theory. It's an application of some theory. And in that theory, when you read the theory, you will get the ideas. The variables are coming from the theory. So there are different variables. When you read the theory, the theoretical framework of your study, variables will emerge, and you can find out whether there is a relationship between the variables or difference between groups in the variables and so on. So one source, an important source, is the related theory. Second, equally important, is the literature review or previous studies. When you read the previous studies on your topic, they have studied different variables, they have formulated hypotheses, they have given questionnaires. So when you do your literature survey, you get a very clear idea about the variables related to your study and the possible hypothesis that were studied and that can be studied by you also. So that is another source. Then you have the personal experience and intuition. Intuition is very important, because when you are doing a study, you think a lot, you read and understand, try to understand, think about it, and then your personal experience and intuition will come into play and will help you to form hypothesis, keen observation of what is happening, creative thinking. So the last three are personal, and that depends upon you, how far you exert yourself by keen observations and intuition and creative thinking. In every research, creative thinking is important, because we have to find out something new, in the sense that something which is already known, from what is known, we have we can express statements in different ways. So how should we express a hypothesis? I hope you are seeing the slide. Okay. Can you see? Can you see the slide?
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Ah, yes.
Yes, sir.
Okay. Okay.
Sir,
Yes, sir.
right.
Yeah, because there was a power change over here, so I thought something happened there. Okay, fine. So hypothesis format. So it is a statement. We know a statement, but in English language, the statement can be expressed in different ways. How do we express a research hypothesis? This is a research hypothesis. How do we express a research hypothesis? Let us look at some formats of hypothesis. If-then statement. It's called an if-then statement. If employees are more healthy, then they will take sick leave less frequently. So there are two factors. One is the health of the employee. The other is the frequency of leave. So these two factors are connected. If employees are more healthy, then they will take they will take sick leave less frequently. So the health and the frequency of leave are connected here through a statement. Right. This is one way you can express a statement. You can connect two variables. Or you can have a directional proposition saying women are more motivated than men, or men are more motivated than women. So here the variable is motivation. The two groups of people are men and women. So we are speaking about motivation, women and men. So we are saying that it's a directional statement. Women are more motivated or men are more motivated. We do not know. We are expressing a statement. The greater the stress in the job, the lower the job satisfaction. So there are two variables here. One is the job satisfaction. The other is the stress in the job. So the two are connected. We are connecting the two. The greater the stress in the job, the lower the job satisfaction. So they are having opposite relationship. The relationship is opposite here. So the another statement it's a statement expressed in a particular way. The question is this the way that we have to? This is meaningful, understandable. Everybody can understand these statements. You read the statements, you understand the meaning, you understand the variables. So they are statements properly expressed in English. But are they? Is it the format in which a research hypothesis should be expressed? Non-directional statements. Sometimes we may not want to have a directional statement. We can have a non-directional statement. There is a relationship between age and job satisfaction. See, there is a relationship between age and job satisfaction. So the two variables are age and job satisfaction. We are saying that there is a relationship, but non-directional. We are not saying that the more the elderly you are, less job satisfaction, or the more aged you are, the more job satisfaction you are having. We are not saying, we are not giving a directional statement. We are simply saying there is a relationship. Or there is a difference between the productivity of American and Asian employees. There's a difference between productivity of American and Asian employees. So to the two groups here are American employees, Asian employees. The variable is productivity. So we are saying that there's a difference. We are not saying that the American employees are more productive than the Asian employees, or the Asian employees are more productive than the American employees. That is a directional statement. This is a non-directional statement. Again, the question is it the correct format for a research hypothesis? The answer is no. This is not these formats are correct in English language. They are correct English. The English teacher will give you full marks if you make these statements, because they are grammatically correct. But this is not the format in which a research hypothesis has to be expressed. There's a different format, and that is what we are going to see. It's called the null and alternate hypothesis. You are familiar with this, I know that, but I'm repeating so that you get used to this. The null and alternate hypothesis. The null hypothesis. Null means no. So it's a proposition stating that there is no significant relationship between two variables. So we are saying that there is no significant relationship between two variables. See, I'll give you examples, then you will understand it better. So this is a null hypothesis. Proposition stating that there is no significant difference between two groups. There are two groups, American employees, Asian employees, or men and women. We are saying that there is no significant difference between the two groups. No difference. No relationship, no difference. Proposition stating that a specific characteristic does not exist. No, does not exist. This characteristic does not exist. So this is a null hypothesis. So when you see the example, you will see how to express it. Now here there's this very important word used here. No significant relationship. No significant difference. What is that significant? We'll understand that later. Just note the word. We are not saying that there is no relationship or no difference. We are saying that there is no significant relationship, no significant difference. So that word is important. In fact, the full expression is there is no statistically significant relationship. There is no statistically significant difference. That is the full expression, but sometimes we don't use the word statistically. It is understood. So we will see the meaning of that later on. Okay. Now the alternate hypothesis is we are saying that there is a relationship, there is a difference, and there is the existence of the characteristic. Statement proposing significant relation. Significant, again the word significant. Relationship between two variables. Statement proposing significant difference between two groups. A statement proposing the existence of a specific characteristics in a group. So these are the two. Sometimes we may express both the null hypothesis and alternate hypothesis, but sometimes we may limit ourselves to expressing the null hypothesis, and the alternate hypothesis are understood. We may not explicitly state it. In a research article, there is a page limitation. Your article has to be limited to 3 pages or 4 or 5 pages, then you cannot have all the hypotheses there. You may limit yourself to null hypothesis. In a PhD thesis, there is no page limitation, so you can have your both the null hypothesis and alternate hypothesis. But null hypotheses are enough because the alternate hypothesis is understood from there. Now let us look at some examples so that you get used to. H0 means null hypothesis. There is no association between advertisement expenses and sales volume. There is no significant association. Actually, the full hypothesis is that there is no significant association between advertisement expenses and sales volume. Okay, null hypothesis. The alternate hypothesis H1 is there is positive association. There is positive association between advertisement expenses and sales volume, or you can say there is negative association. Positive association means as advertisement increases, sales will increase. Negative association means as advertisement increases, sales will decrease. That is negative association. So we are saying alternate hypothesis. So this is H0 and H1. Another example, there's no difference in the performance score of boys and girls. There is no significant difference in the performance score of boys and girls. So we are saying that the score of boys and girls are the same. H1, there is significant difference in the performance score of boys and girls. So, significant, who is having more, we are not saying. We are simply saying that there is significant difference in the performance score of boys and girls. But this may sometimes be expressed as the performance score of boys is higher than the performance score of girls. The performance score of girls is higher than the performance score of boys. It can be expressed in that form also, but ideally, this is the standardized form, H0 and H1. There is no significant difference. When you are doing the hypothesis testing, we will find out who is having more score, boys and girls. Here we are simply saying that there is no significant difference. So the result of testing will be 3. 1. Either you will get the result that there is no significant difference, or you may get the result that the boy score is higher than the girl score, or you may get a difference, or you may get a result that the girl score is higher than the boy score. So 3 alternative answers are possible when you are doing your testing. Now, the third type of hypothesis is dealing with the characteristic. There is no stress related job in the banking sector. Supposing you are studying the banking sector and your null hypothesis is that there is no stress related to job in the banking sector. Alternate hypothesis, there is high stress related to job in the banking sector. That's the alternate hypothesis. So in a research study, the hypothesis can be formulated as a null hypothesis or alternate hypothesis. But we focus on the null hypothesis because we want to be unbiased. A researcher has to be unbiased. We are not favoring the existence of stress or difference or association. We are starting from the position that there is no association, there is no difference, there is no stress. Then you do collect your data, do your testing, and then you come to the conclusion and you test the hypothesis and you find out whether this statement is true. If this statement is not true, then you reject it and then you accept the alternate hypothesis. So this is how we do. So our focus is on, as an unbiased researcher, our focus is on the null hypothesis. We will test it and accept the alternate hypothesis if the null hypothesis is rejected. Some more examples from research studies, from actual research studies. There was a group meeting effectiveness, that is the SHGs, that is self-help groups. There was a study on self-help groups, how they empower women and so on. So there was a group meeting happens in the SHGs, and the effectiveness of the group meeting was measured with the scale through a questionnaire, and there is a null hypothesis. There is no significant difference in group meeting effectiveness across rural and urban SHGs. So that the group meeting effectiveness is tested, measured quantitatively as a number. You get a number by using, in the questionnaire there are several statements and the statements are measured through a scale. So a score is there, group meeting effectiveness score is there, and we are saying the null hypothesis is that there is no significant difference in group meeting effectiveness score across rural and urban SHGs. So we are unbiased. We may sometimes think that the urban SHGs are having a higher score because we expect the urban SHGs to be more educated, literate, and so on. So we expect that sometimes their group meeting effectiveness will be higher than the rural. So that is all our expectations. Then if you go by that expectation, then we are biased. As a researcher, we become biased towards the urban SHGs. We have to remain unbiased. Therefore, we say there is no significant difference. We will test it and find out whether there is a more score for urban rural. That will come from the test result. But in our study, we are unbiased. We are not biased towards the urban SHGs. There is no significant difference in group meeting effectiveness across North, Central, and South Zone SHGs. In the study, it was a study on Kerala. There were SHGs from North, Central, and South Zone. So whether there is any significant difference between the three regions. There is no significant difference in group meeting effectiveness across small and big SHGs. See, there is no significant difference in group meeting effectiveness across small and big SHGs. So again, big SHGs, we may assume that the big SHGs are having a higher score. Naturally, because logically thinking that they will be having a higher score, but then we will be biased. We have to be unbiased. So we state that there is no significant difference in the group meeting effectiveness across small and big SHGs. And we have to use the test for the first one. There are only two groups, rural and urban. So there we will be using what is called a t-test. In the second one, there are 3 groups, north, central, and south zone. So there we'll be using ANOVA. And the third one, again, there are only 2 groups, small and big. Therefore, we'll be using a t-test. I'll come to that testing later on. Again, from research studies, actual research studies, some examples. Association between variables. Let's look at this hypothesis. There is no association between the level of entrepreneurial traits among the trainees and the impact of the training program. So we are studying 2 things here. One is the impact of the training program, and the other is the entrepreneurial traits among the trainees. So if they are having, so again, we may expect that if the trainees are having entrepreneurial traits in them, the impact of the training program may be more. That is an assumption, but that assumption makes us biased. Therefore, we are saying that there is no association, no relationship between these two. But when you're doing the testing, you may find that there is an association. That is a statistical result. It's not assumption. There's no association between the index values of LSE and BSE, London Stock Exchange and Bombay Stock Exchange. So these are the index of London Stock Exchange and Bombay Stock Exchange. So is there an association between these two, or is there no association? We may think that London Stock Exchange is an old stock exchange, is a big stock exchange, is a stock exchange of a developed country, and therefore we may assume that the value of the London Stock Exchange is more than the value of the Bombay Stock Exchange. Then we are biased. We should be unbiased. So we say there is no association. Let us test and find out. There's no correlation between the daily returns of gold ETF and index ETFs. Most of my studies were on the stock market and so on. That's why these hypotheses are coming up. Gold ETF, exchange traded fund, is a product in the stock market. There are gold ETFs and index ETFs. So we say that there is no correlation between the daily returns of gold ETF and index ETF. We have to find out whether there is any relationship. So to find out the association between variables, we can use correlation or regression. There's no association between future market prices and spot market prices of agricultural commodities. So some of you might have studied, MBA students, even MCOM students would have studied derivatives. I have a book on derivatives, commodity and financial derivatives. It is being used for MBA. So these derivatives are very important in the stock market. So there are future market, futures price and spot price. For agriculture commodities, what is the spot price? What is the future price? Futures is a derivative. So is there any association between these two, or are they not related? That is a very important question in the derivatives segment. So this is a study on that. Again, some more examples. I hope I am not boring you with all these examples. Okay. Examples will clarify. That's why I'm giving examples. Existence of specific characteristics. We are studying 3 types of hypothesis. That is, one is association, the other is the difference, the third is the existence of specific characteristics. So let us see. There is no volatility spillover from the spot market to the futures market in the case of agricultural commodities. Volatility means the high changes in the prices. When the prices are changing, we say it is volatility. Is there a spillover from the spot market to the futures market? We say there is no volatility spillover from the spot market to the futures market. But is it the case? We have to test and find out. Then USD means US dollars, INR, Indian rupees. Exchange rate. So there's an exchange rate between Indian rupees and US dollars. So the exchange rate series, if we take a series of exchange rates for 200 days, 300 days, 500 days, and we get a time series, and we use econometric analysis there. So in a USD INR exchange rate time series exhibits homoscedasticity, constant variance. So that is an econometric feature, constant variance. That variance is constant, we are saying. The opposite is constant variance means that is a null hypothesis. The variance is not constant, then we say it is an alternate hypothesis. Okay. These are technical terms. That is, the series does not exhibit heteroscedasticity or unequal variance. Okay, that's enough. Two examples will bore you. Okay, so what we have seen so far is, what is a hypothesis? How do you formulate a hypothesis? We have seen that commonly hypothesis can be formulated in three different ways. One is association, other is difference, other is the existence of characteristics. Now we are coming to the second part of our topic, which is the hypothesis testing. What are the steps used in hypothesis testing? I have another presentation on hypothesis testing, but before that, let's briefly mention the steps involved here. We first of all state the null hypothesis and the alternate hypothesis. We have seen several examples. So in a PhD research, we can state there is space for expressing both the null hypothesis and alternate hypothesis. Fine. Then we have to choose an appropriate statistical test for testing this hypothesis. If it is a hypothesis regarding relationship, what is the test to be applied? If it is a hypothesis regarding difference, what is the test to be applied? If it is a hypothesis regarding the existence of yes. Okay, no problem. So you have to choose the appropriate test. What is the appropriate test to be applied? We will see. I will come to that. Now here, remember, now the trend is you give the data to a statistician to do the analysis. He will apply SPSS or some other statistical packages to do the analysis. All that is fine. And you may not be able to do the analysis. If you can do the analysis, study SPSS and do it, excellent. I would suggest that. Study SPSS and do it. Or you can even do it in Excel. There's Megastat, something called Megastat. You can download it freely and do all your analysis in Megastat. Try to learn it. That will be the most appropriate thing to do. But if you are entrusting it to a statistician, well and good, there's no problem. Only thing is you lose some money. Doesn't matter. But then you should know what are the tests to be applied. He may suggest the test. You should be able to say, okay, that is the correct test to be applied. Then when he gives the result, let him do the analysis. But when the result comes, as a researcher, you should be able to understand and interpret the meaning of the research. He may write it down for you, give you the guidance, but as a researcher, we should know what is the interpretation, what is the meaning of the result. At least that we should know. So we should be, as a researcher, you should know which is the test to be applied for testing the hypothesis. Then there is something called the level of significance desired. What is the level of significance desired? Usually in social sciences, we require a 5% significance level. 5% significance level. So remember the 5% significance level. What it exactly means, I'll come to it shortly. The third step is you apply the test to the sample data. You do the t-test or ANOVA or chi-square test or regression or correlation, whatever is the test to be applied. Apply the test to the sample data. Sample data. See, that word is very important. Your data has been collected from a sample. Your data has been collected from a sample. So it is a sample data. And you are applying the test to the sample data. Supposing you are studying the relationship between advertisement and sales. You have a sample data. And you apply the test correlation, simple correlation, and you find that there is correlation. Right. So in the sample, you select the data from one company or two companies for 5 years. So it's a sample data, 5-year data of one company. There are so many companies in India, in the world. So the population is, supposing you're studying in Kerala or India, the population is all the companies in a particular industry will be your population. But you have selected one company, 5-year data, it's a sample data. And you apply the test of correlation and you find that there is correlation. So there is association, correlation between advertisement and sales in the sample. There's no doubt about it. You got the result. Now, the question is there the same relationship in the other companies, in the population? In the population, in the sample, you tested it, you got a correlation result, 90.90, 0.85. So high correlation in the sample data. But we are not interested in this particular company. As a researcher, we are not interested in the sample. We are interested in the population. Sample is selected for convenience. We cannot select the data from the population. It's impossible. Inconvenient. Therefore, we select the sample from the data. That is for convenience. But we want the result, we want the finding to be applied to the population. So our question is there an association between advertisement expenditure and sales in the population? That is statistical testing. That is called the testing of the hypothesis. So in the hypothesis testing, there are two steps. The first step is apply the test to the sample data and you get a result. And in the sample, there is correlation. That is the first step. Second step is we want to know whether this same relationship exists in the population. That is statistical significance testing. Statistical significance testing. How do we do that? That is what we are going to study. The second part. The first part is very easy. You simply apply correlation or regression or ANOVA or t-test to the sample, and in the sample you find difference or association. There is no doubt about it. Nobody will question you. It is very clear. But that is not what we are interested. We are interested in the population. In the population, is there such a difference? Is there such a relationship? How do you find out? And that is really statistical testing. How do we do that? We will come to that later on. So apply the test to the sample data, then accept or reject the null hypothesis based on the test result. So based on the statistical test result, you will accept or reject the null hypothesis based on the test result. And how do we do that? That is what we are going to see. Okay. So before that, see, let me go back to one of the hypothesis here. A very interesting aspect here. See here. Take this hypothesis. There is no association between advertisement expenses and sales volume. Actually, the full hypothesis is there is no association between advertisement expenses and sales volume in the population. There is no association between advertisement expense and sales in the population. That is what we are testing. That is what we are testing. Not the sample. Sample we are not testing. Sample, when you apply your correlation, you get the result. So so that is understood here. It is not expressed here. There is no association between advertisement expenses and sales volume in the population. Alternate hypothesis. There is an association between advertisement expenses and sales volume in the population. How do you find that? You have done correlation only for the sample data. See, you have done your correlation only for the sample data. But then, do you accept this null hypothesis or reject the null hypothesis? The hypothesis is there is no association between advertisement and sales in the population. How do you accept that or reject that? That is hypothesis testing. See, there's no difference in the performance score of boys and girls in the population, not in this class. We are not speaking about a particular class. In that class, there may be a difference that we can find out by t-test. When you do your t-test or when you take the mean, you will find out whether there is a difference between the boys score and the girls score. But our hypothesis really is, this is not the hypothesis, our hypothesis really is, there is no difference in the performance score of boys and girls in the population. How do you find out? For that, we have to do what is called statistical testing. You'll see how that is done. Now I have introduced the concept of statistical testing. Significance testing, it is called significance testing. Okay, these are the steps here. So we are dealing with sample data, so we require sampling. You are all familiar with sampling. I don't have to mention about sampling. Hypothesis testing is done after data collection from the sample. Data are usually collected from a sample selected for the study, not from the population. Sampling is selecting for the study a part of the universe or population relevant to the study. You know that. Sampling is selecting a part of the population relevant to the study, and there are different methods of sampling. The sample may be small or large. When it is less than 30, it is small. More than 30, it is large. The sampling method may be random or non-random. I'm not going into all those. That is another part of the research process. Random or non-random sample methods. Methods of sampling are: random sampling is method of selection wherein each unit has an equal chance of being selected. Lottery method is the ideal method. Random sampling, non-random sampling are stratified random sampling is the universe is subdivided into strata like men, women, or rural, urban, etc. And then from each strata we are taking a random sample. It's called stratified random sample. Depending upon your population, your study, the nature of your study, you may require a stratified random sampling, or you may require purposive sampling, which is a non-random sampling method. The selection criteria is subjective based on the researcher, like convenience or availability of the people and so on. That's called purposive sampling. Or you're collecting data for a particular purpose. Right. Now, this again, statistical inference. Statistical inference, very important word, statistical inference. Results of the sample study are projected onto the universe. Results of the sample study are projected onto the universe. So we get a result when you are doing your correlation or regression or t-test. You are getting a result which is applicable to the sample. There is a difference or there's an association in the sample. Fine, no problem, no doubt about it. But what about the population? So from the results of the sample, we have to project the result to the population. That is called statistical inference. We are making an inference about the population. From the sample study, we are making an inference about the population. Significance testing, it is called. Significance testing helps to make valid inferences regarding the universe or population from the results of the sample study. So from the results of the sample study, we have to make an inference. It's only an inference. It's not a final conclusion. It's only an inference, but it is based on statistical evidence. So it is called statistical inference or significance testing. Okay, so how do we do that? That is what we have to. Now it is kept in suspense. In my next slide, will show you how we have to do the statistical inference or statistical testing from the results of the sample study. Okay. I will stop this. Whatever doubts you have, you can keep it ready. Let me go to the next PowerPoint. Yes. Can you see the slide?
Yes, sir.
Okay,
Visible.
fine. This is the University of Kerala main office in Trivandrum. Okay, Maharaja statue is there in front. Okay, I was fortunate to be there. We were, myself and Dr. Iqbal, we were the ones who installed the statue there in front of the university, because it's the Maharaja who started the university in 1937. Okay. Right, so hypothesis testing. Now we are coming to the testing part of it. For hypothesis testing, we have to use statistical tools. And there are different categories of statistical tools. So I'm just familiarizing you with these statistical tools, just mentioning the different categories. Statistical tools are used for different purposes. Different purposes, remember. Descriptive statistics, describing the features or characteristics of your data, like mean, median, mode, standard deviation. So you find out all these things. In fact, your research study will start with the descriptive statistics of your data. From your data, you start with your descriptive statistics. Then we have something called inferential statistics. There we are estimating the population parameters from the sample statistics. So we have sample data. We calculate some statistics from the sample data, like mean, median, t-value, z-value, etc. These are called sample statistics. From the sample statistics, we are making some inference about the population parameters because we are interested in the population. I told you our hypothesis is there is an association between two things in the population. There is a difference between two groups in the population. So we have to make an estimate, but we are not collecting data from the population. So therefore, from the sample results, we are making an inference or estimation about the population. And for that, we use statistical methods or tools. And such statistical tools are called inferential statistics. So for hypothesis testing, we are going to use inferential statistics. Then we have complex relationships. And we use multivariate analysis like factor analysis or discriminant analysis, SEM, structure regression modeling, and so on. There are so many multivariate analysis. Depending upon your study, if it requires some multivariate analysis, you can do that. Then if your data is a time series data, then we have to measure the growth rates of the time series, and we have to understand how to predict the future data and so on. We have something called a time series analysis, and there now econometric tools are also being used in time series analysis. A very interesting type of analysis, altogether different type of analysis, time series analysis. So here we are going to concentrate on, I'm going to stress focus on inferential statistics. The statistics I'm leaving out. Inferential statistics is concerned with making inferences from samples about the population. So from the sample result, we are going to make some inferences or estimates about the population. And for that, we use a group of statistical tools called inferential statistics. For example, if we find an association between two variables in the sample, we would like to know whether it is a real association. That means, is it there in the population? Or is it there only in this sample which occurred by chance? So is it a chance association occurring only in this particular sample? Or is it there in the population also? Is it real? Or is it only a chance association? How do you find that? We will use a statistical technique for that. If we find a difference between two samples, two groups, say men and women, rural, urban people, we would like to know whether it is a real difference in the population or a chance difference occurring only in this particular sample that you collected. So is it a real difference or is it a chance difference? This is what we want to know. So inferential statistics are used for hypothesis testing because our hypothesis is about the statements about populations. Our hypotheses are all statements about population. So we are going to say whether there is a real difference or real association in the population using inferential statistical tools. Types of inferential statistical tools. If you want to study association between variables, we use, so we have tools for the study of association. We have tools for the study of difference between groups. So as a researcher, as I said earlier, as a researcher, you should know which is the appropriate tool. Let the statistician do the analysis, no problem. But you should know clearly which is the tool to be applied. Is the tool that he is applying, is it correct? Is it appropriate? And what does it mean? What does it measure? What is the interpretation? Those are the things that you should know, not the actual application. Okay, so the study of association between variables, we use two statistical tools. One is correlation, the other is regression. Correlation and regression are used for studying the association between variables. Correlation, it is a study of association between two variables. You get the value, the results will be, so it's a measure of covariation. It indicates the magnitude and direction of covariation. You may have the result as positive or negative. The result correlation coefficient is R. It may be positive or negative. It may vary from ±1 to +1. So it may be negative. The maximum is 1. So 0 to 1, either on the negative side or positive side. So if it is 0.9, there is high correlation. If it is 0.10, 0.20, etc., then there is low correlation. All those things you have studied from your BCom days itself, you have studied. And the R square is called coefficient of determination. It measures the extent of variation explained by the relationship. R square, supposing R is 0.8, 0.8 into 0.8, 0.64. That means 64% of the variation is explained by the relation between advertisement and sales. Supposing you're studying the relationship between advertisement and sales and the correlation is 0.8, R square is 0.64. That is 64% of the variation in sales is explained by the advertisement. The balance 34% is explained by some other factors. Okay, these are things relating to correlation. The question is correlation significant? Is correlation significant? First of all, you should understand the meaning of this question. Supposing in your Viva, you say, I got a correlation of 0.8, 0.9. Immediately the examiner will ask you, is this correlation significant? So what is the meaning of this question? When you ask the question, is the correlation significant? What it means is this correlation applicable to the population? Is this correlation applicable to the population? That is the question. See, the correlation is there. You got a correlation of 0.8 in the sample. You say, I have a correlation of 0.8. Fine. That is in the sample. I'm not interested in your sample. Forget about your sample. I'm interested in the population. So I ask the question, is correlation significant? That means, is this correlation existing in the population? That is the most important question. That is what I am really interested. How do you find out? So that is hypothesis testing, significance testing, etc. See, universe parameters are inferred from the sample statistics. So sample statistics or sample correlation in this case is 0.8. What is the universe correlation? In the universe, what is the correlation? Is it near to 0.8? We have to infer, estimate. When correlation is significant, if you find out that correlation is significant, the inference is that the correlation exists in the population also. That is the meaning of saying that the correlation is significant. And what is the value? What is the statistical tool used? The statistical tool used is the p-value. The p-value, probability value. So along with, when you're doing your analysis in your software, you will get, along with your correlation result, you will get a p-value. And the p-value indicates the probability of the correlation occurring by chance. P-value indicates the probability of the correlation occurring by chance. So the lesser the p-value, lesser the chance of correlation by occurring by chance, and higher the correlation being really in the population. So lesser the p-value, higher the probability that it is a real correlation. because p-value indicates the probability of correlation occurring by chance. So this is the rule to be applied. You may know the rule. If p-value is less than 0.05, correlation is stated to be significant. Correlation is stated to be significant. So, and this 0.5 is called the significance level. Earlier I mentioned that significance level. You have to determine the significance level. In social science, we use the significance level of 5%. That is this 0.05. So if p-value is less than 0.05, we say correlation is significant. So here the significance level is taken as 5%. So you can take your significance level as 1%. In sciences, in real physical sciences like physics, chemistry, etc., they use 1% as their significance level because they want more accurate results. So there the p-value, they will accept the result only if the p-value is less than 0.01. Significance level for physical sciences is 1%. For social sciences, generally it is 5%. Okay. Again, another, I'll explain it in a different way. What do you mean by this 5% significance level? It can be understood in a different way. You took a sample here. You got a result, 0.8. Correlation is 0.8. And the probability is, say, 0.05 or less than 0.05. Let us say 0.04. Your probability is 0.04. What it means is, see, remember this points. What is this p-value there? The previous CC here. P-value indicates the probability of the correlation occurring by chance. So if your p-value is 0.04, that means if you take 100 samples from the same population, you have taken one sample now. You take 100 samples from the same population and do the correlation test. In 96 cases, you will find a high correlation very near to 0.8. But in 4 cases, your correlation will be very far away from that 0.8. So that is by chance. By chance, in 4 cases, you may not get a high correlation. In 96 cases, it will be almost near to your 0.8. Or in other words, 1 minus the p-value gives you the confidence level. So with the 96% confidence, you can say that your correlation exists in the population also. But there may be exceptions. In 4 cases, in this particular case, in 4 cases, the correlation may not exist. But we are prepared to accept that because we have selected your significance level as, your significance level has been selected as 0.5%. Therefore, that 4 chances of occurrence we are prepared to accept. So this is the real meaning of significance testing. And this is applicable, once you have understood this concept, this is applicable in all the statistical testing tools, whether it is t-test or ANOVA or chi-square test or any test, whatever is the test that you are applying, it will be the same rule will be applicable and the same logic is applicable, which I explained to you. Okay. There is another approach to there is a, let me show you. There is another approach to when you're doing your correlation in SPSS. The correlation analysis result will include critical values of R for 5% and 1% significance level. When you do it in SPSS, what you get is you will get critical values for 5% level of significance and 1% level of significance. And if the actual values of R exceeds the critical values, correlation is said to be significant. So if the actual value is exceeding that critical value, then we say it is significant. 5% significance level in only 5 out of the 100 samples from the population, the correlation may not exist. That was what I was explaining. 5% significance level means in only 5 out of 100 samples from the population, the correlation may not exist. Okay, let me show you an actual result here. Actual result. See here, this is the data. See the English score and math score of 12 students. Can you see that? I hope you can see it. I'll make it bigger. Okay. English score, math score of 12 students. So we want to know whether there is a relation between these two. We are doing the analysis, and our null hypothesis is that there is no signal, there is no association between the two scores. But let us do the analysis. Let us see the output here. This is the output from your, see here. Can you see that? Let me make it bigger. Okay, see here. See here. Correlation matrix, English score, a math score. The correlation is very high, 0.967. See that in yellow ink, it is yellow color, it is marked. The correlation between the two is 0.967. The 12 is the sample size. See the critical value for 5%. Can you see that the critical values for 0.05? That is for 5% significance level, the critical value of correlation is plus or minus 0.576. So if your actual result is more than this critical value, that means there is a significant correlation in the population also. So this is the critical value. Your actual correlation value should be above this critical value. Then you can say that there is a correlation between the two scores. Your null hypothesis that there is no correlation between the two scores will be rejected, and your alternate hypothesis will be accepted. So when you do your analysis in SPSS or Megastat, this is the way the result will come, and this is how we find out whether the correlation exists in the population also. Okay, so I just wanted to show you an actual result. Right, so we move to the next one. Let me see. I'll just, what is the time now? I'll stop by 7:15, okay? Then I will have question answer session, so another 10 minutes. Hypothesis testing of association between variables. I told you there are a lot of things to say, but in an online class, there are limitations. Analysis of difference. So let us look at the analysis of differences. In correlation regression, the association between different variables in one sample is studied. Example, advertisement and sales. But in the analysis of differences, the value of one variable in different samples are studied. The value of one variable, the performance score of boys and girls in different samples are studied. Say advertisement expenditure in the private sector and public sector. So private sector firm is one group, public sector firms are the other group. Advertisement expenditure, is there a difference in the advertisement expenditure? So that is called, are the differences in the values of the variables in the two or more samples significantly different? So what we are looking for is whether there is a difference in the advertisement expenditure in the private sector and public sector firms in the population. Not in our sample, in the population. How do you do that? What are the tests to be used? The appropriate test here is a test. Difference between two groups when large samples. When you have two groups of large samples, we use what is called a Z test. Then difference between two groups for small samples, we use t-test. Difference among more than two groups, we have F-test or ANOVA. Now we are in the computer, we are doing the analysis through computers. Therefore, we do not speak of Z-test. We speak of t-test because the computer will look at the sample size and decide. The formula for Z-test and t-test are different. There's a slight difference in the formula for Z-test and t-test, but we are calling all tests as t-test. For two groups, the tests that we use are called t-test because the computer will look at the sample size and decide which formula to be applied. So we are not worried about, we don't have to call it Z test and t-test. We simply call it t-test. The computer will take the appropriate formula to be applied. So basic logic is the means of the different samples are used for testing. Say boys mean, boys score mean, girls score mean, or public sector score mean, private sector score, the mean of the score is selected. And does the difference in the sample means reflect the difference in the population means? See that? That is the question. Does the difference in the sample means reflect the difference in the population means? Is it a t-test, f-test? Answer this basic question. Types of Z-test and t-test. I just mentioned the types of Z-test and t-test. There is something called one-sample t-test. One-sample t-test. Perception of employees regarding stress. See the existence, we said about the existence of stress in the bank employees. So perception of employees regarding stress in the job, we can use one-sample t-test, or you can use independent sample t-test to test between boys and girls, or men and women, or rural and urban, etc. Or we can have a paired sample t-test when the two groups are the same pair. See, pre-training score versus post-training score of the same group. So we have a group of trainees. We take the pre-training score and the post-training score of the same group. There we use what is called a paired sample t-test because the two scores are pairs. If they are not connected, boys and girls, they are not connected. Therefore, we use independent sample t-test. If you are studying only one group, we are not studying two groups, then we have one sample t-test. So what we do here is very simple. How do we interpret the result? The Z value or T value is computed. The P value is also generated through the calculations. See, along with the Z value or T value, P value is also generated. And this P value is the most important value for statistical testing or hypothesis testing. The P value indicates the probability of the difference between the means occurring by chance. I mentioned it earlier. This is the rule, the same rule. If P value is less than 0.05, the null hypothesis that there is no difference is rejected. There is no difference is rejected. The alternate hypothesis will be accepted. So if P value is less than 0.5, we say there is a real significant difference in the population also. The difference is significant. It means it exists not only in the sample but also in the population. Yes, one sample t-test. I just mentioned this one sample t-test and then conclude. It is also known as a single sample t-test. There's only one sample, one group, not two groups. It's commonly used to test the difference between the sample mean and the midpoint of the scale used to measure the variable. For example, we have a sample. The sample is group of employees, bank employees. The variable is perception regarding their job stress. This perception is measured by using a measurement scale called a Likert scale. Fully agree, partly agree, neutral, disagree, fully disagree. That 5-point scale is used. So we have a score called the perception regarding job stress. You take the mean. Suppose the mean is 3.8 or 4.2. So does it mean that there is high stress? Is it really? We got for this sample, this particular sample of employees that we have selected, we got a score of 4.2. Okay, in the 5-point scale, we got a score of 4.2. That is the mean score of this group of employees is 4.2, which means there is high stress. But that stress is there in this group. Is the same stress level existing in the population? That is what we want to find out. So in this group, okay, fine, there is that stress is there. But does that stress exist in the population? For that, we use a single sample t-test or one sample t-test, and you will get a p-value. Say the sample midpoint is 3. The midpoint of the sample is 3. In a 5-point scale, the midpoint is 3. And the difference, if the difference is statistically significant, it indicates the existence of the job stress in the population. For that, single sample t-test can be used to test the hypothesis regarding the existence of a specific characteristics. We have seen that one way of expressing a hypothesis is the existence of a specific characteristic. So, single sample t-test will be applied. Here, the rule is the same. Look at the p-value. If the p-value is less than 0.05, then we say that there is the stress is there. We reject the null hypothesis that there is no stress. Here, null hypothesis, there is no job stress in the banking industry. We are saying there is no job stress in the banking industry. We are speaking about the population. We are not speaking about the sample. There is no job stress in the banking industry. Test results will include mean score of the sample, t-value, and p-value. So what is the mean score? What is the t-value? What is the p-value? When the mean score is above 3 and the p-value is less than 0.05, it means that the job stress is significantly higher than the midpoint, indicating the presence of job stress. Supposing the mean score is above 3, p-value is less than 0.5, it means that there is job stress in the population, also in the banking industry. The null hypothesis will be rejected. Okay. Okay, I think I will have to move on. I'll have to conclude. Just the last slide, a summary. There are a lot of things here. Anyway. Okay, this is the summary slide. Hypothesis testing as summary. Inferential statistics are used for hypothesis testing. Parametric tests are used when the data are normally distributed. Otherwise, non-parametric tests may be used. I did not show that slide. Anyway, it doesn't matter. Correlation and regression are used for the study of association between variables. T-tests and ANOVA are used for the study of difference between groups. P-value is used to determine the statistical significance of the association or difference. This is the rule. If p-value is less than 0.05, the null hypothesis is rejected. So this is your summary, and I have a book on, I'll just show you the book also. Yes, the last book, book for reference, I have published a book on research methodology for social science, number 4. Research methodology for social sciences. It's published by Ann Books, Delhi. Ann Books, Delhi. You can buy it on Amazon or other online platforms. Books are not available. It was published just before the COVID pandemic. Therefore, they could not distribute it to the booksellers in different parts of the country. So, but it is available online. Okay. Yes, so thank you very much for your patient listening. I hope I was able to fulfill your expectations. I don't know. Let me see the questions. Yes. Yes, organizers.
Thank you, sir, for your thought-provoking as well as extremely informative session on formulation and testing of hypothesis. We are now moving to the Q&A session. Participants have already posted their questions. Shall we move to that, sir? Shall I read it to you?
Yeah, definitely.
Definitely. The first question is from Sri Radha, and she asked for examples for null and alternative hypothesis.
I have already given that in the slides. No, several hypotheses were given. Examples were given. No, so you can share the slide so that she can use it.
Okay, we'll be sharing this slide to the registered email ID to all the participants. Okay, sir. The next question is by Krishna Prakash M. The question is, why we use null hypothesis?
That is what I explained there. You see, the researcher has to be unbiased. I gave you some examples there. So supposing we say the SHGs, the big SHGs, we will automatically assume that the big SHGs have a better score. So then we are biased. So null hypothesis, we are unbiased. The researcher has to be always unbiased, and the result should come from the statistical tests, not from our assumptions. That is why we are using the null hypothesis. Okay.
Okay, so the next question is from Mr. Anil, our participant from Karnataka. The question is it necessary to formulate hypothesis in a qualitative study? If yes, then how to test it as there is no quantitative data?
Yes, the qualitative study is totally different. All this, whatever I have said, are applicable only to a quantitative data. Qualitative data, the methodology is different, so I cannot explain it here. There are different methods there also where we can, instead of explicitly stating the hypothesis, we explain it in different ways. That is there, but the explanation will be too long. Okay. This, whatever I have said here, is applicable to a quantitative study. Okay.
Okay, sir. The next question is from Rahul Upadhyaya. The question is, after collecting data, it is not easy to systematically represent the data. If size of data is big, then there was chances of error. As you know, any error may lead to harm in results. So, how can we reduce these errors? Is there any method available for reducing errors?
What we do is there are several steps. The first step is that the questionnaire should be minimum. That is, we should ask only for the relevant data, and you should use appropriate measuring tools. Second step is the editing part of it. Is the data, we don't accept the data collected as such. There should be an editing process where we go through the data and we leave out some of the data which we find is not appropriate or true, valid. Then we can remove those data. So that's one method. So that is how we normally come to the valid true data, through editing, through the proper questionnaire, through systematic collection, and through editing. Okay.
Okay, sir. The next question is from Ms. Lokeshwari. The question is, what is the difference between test series like t-test, f-test?
T-test is used for testing the difference between two groups. F-test is used for testing the difference between more than two groups. That is 3 or 4 or 5, any number. So if we are testing the difference between two groups, we use t-test. If the groups are more than two, we use ANOVA, or which is called F-test also. Okay.
Okay, sir. The next question is from Bombakanti Sai. The question is, please explain about types of inferential statistics in detail.
I have mentioned some of them because of time limitation. We cannot go into, but in the slide it is there, or the details are there. So you can go through the slide and understand. All the tests are explained there.
Okay, sir. The next question is by Ms. Praveena Krishnan. The question is, what is the minimum sample size to check a hypothesis through a survey?
For sample size, there are certain formulas out there based on the population, whether the population is definite or indefinite. There are two different formulas. Cochrane's formula is there. So you have to apply that formula and find out what is the sample size.
Okay, we have one more question related to that by Ms. Jayalakshmi. How to determine the sample size if population is finite? When we try in online, how many ever the population size, the sample shows less than 400.
Usually, when we use Cochrane's formula, we get around 380 is the sample size that we get, So more than 380, we should use, depending upon the sample we can apply the formula and find out the sample size. Usually it comes around 380, 370, etc. So then your sample should be more than that. That is the minimum size. Okay.
Okay, sir, we have one last question by Ms. Priyanka. The question is, if we have two categorical variables, that is districts and membership, is it good to include both for testing the same variable for satisfying a single objective?
Now there is no problem because see, I showed you one example where that self-help groups we were testing across groups, small and big, north zone, south zone, central zone, then again rural and urban and so on. So even if we can test using different categorical variables, the more tests that you do, the more your result is confirmed. So I would recommend the use of both the categorical variables. Okay.
Okay, sir. We have got one more question
Yeah.
now.
Yes.
The question is from Mr. Alok. The question is, if we talk on individual companies' balance sheet, work will be elaborated. So how far it is viable to talk up on making sigma of all the company's data and interpret it as industry analysis?
Yeah, for industry analysis, we should definitely have more companies only then we can represent the industry. So if we are doing an industry analysis, definitely we should have balance sheets of different companies. Then do the analysis. Because
Sir,
now analysis is easy because of the computers and softwares.
yeah. Sir, good evening, sir.
Good evening.
Sir, actually, my doubt is if I write an interpretation for single company on the balance sheet, and I am going to select a number of companies, say 10 companies or more than 10 companies. So I have to keep on writing for individual company as an analysis, sir. The work will be elaborated. So my question is, can I make the summation of the financial statements data of all the companies together and write an interpretation as an industry, whether the output will be viable, whether it will be contributing or not?
Yeah, you can summarize the data. There's more data. If you are collecting data from 10 companies, it's good. But you summarize the data. You don't have to show the balance sheet fully. You have to, supposing you take sales. So sales of the 10 companies will be summarized into a mean. You get a mean value. So
Yes.
summary statistics are enough.
Yes.
Summary statistics are enough. Okay.
So the output will be viable, sir, if we write as an interpretation.
Yeah, definitely. The more companies you have, the better the result.
Yes.
That is the result.
Okay. Thank you. Thank you for the question.
Right.
Thank you so much, sir. We have come to the end of the Q&A session. That was the last questions that we had.
Yes.
Okay, we have one more question, I guess.
Yeah.
It's from Mr. Mohammed Jainal Abidan. The question is, should qualitative research cover the hypothesis?
See, normally qualitative analysis does not have hypothesis. They are describing some features. So they will explain the features and they will analyze and explain from evidence. So normally hypotheses are not used. Okay.
Okay, sir. Thank you.
Sir,
Because-
I would like
We
to
are-
ask one question.
Yeah.
The thing is, I've already put the question in the group and it was discussed. Sir, however, the population value, if we put it online, we are getting only 380, 370, as you said. Whether it is a feasible one to take that?
That's a sample. Okay. See, whatever you are collecting online or offline, see, it is a sample data collected offline. The method of collection is online, that's all. Data is the same.
Sir, not the method. I am asking that the formula what we are applying to determine the sample size.
The sample size has to be determined based on the population. So you say the population is indefinite. You assume
No,
that
population is finite. So
then you have the
whatever the size, it is showing only 370, 380 value. It is not showing more than that.
yeah. That's all. That's what I said. It will be around 370. The sample
Yeah.
size will be 370. That is correct. So your actual sample should be more than that. That's all.
Okay, that can be 450 or 460, whatever it is.
That's better. If it is higher than this, better.
Okay, sir. Okay. Thank you so much.
Okay. Right.
Thank you, sir. Thank you, all the participants. We are indeed glad to receive lots of commendable responses and remarks from the participants. The PowerPoint presentation will be shared to you in the registered email ID. And thank you, sir, for sharing the information regarding your book on resource methodology for social sciences. All the participants can buy that as well online. Thank you, sir.
Okay.
As a token of acknowledging the speaker, I invite Dr. Anu Anthony, faculty of the Postgraduate Department of Commerce and the IQAC coordinator of Christodoli College of Management and Technology, who is also the organizing secretary of this session, to present the certificate of appreciation to our resource person, Dr. S. Kevin.
Okay. Very good, very good. I was reading this. It's very good. Okay, you can send it by email. I'll take a copy of the certificate, right? Very
Yes,
good.
sir.
Okay.
Thank you, ma'am, and thank you once again, Dr. S. Kevin, for the engaging session. To express gratitude to all gathered here virtually, I invite Mr. Kristen Matthew, faculty of the Department of Management of Christodoli College of Management and Technology.
Jeremy, am I audible?
Yes, yes.
Yes, sir, you're audible. You're audible.
Okay. Good evening to one and all present here. Resource person of today's session, Dr. S. Kevin, former Pro Vice Chancellor, Kerala University, respected Principal, Reverend Father Joshi Chiramkudi CMI, Vice Principal, Dr. Varghese Anthony Sir, HODs, faculties, and research scholars from various institutions, and all the participants. It is such an honor for me to give word of thanks on this occasion. I would like to express my gratitude to our honorable resource person, Dr. S. Kevin, former Pro Vice Chancellor, Kerala University, to take out time from his busy schedule to take a session on formulation, and testing of hypotheses. I hope that we all got a clear idea regarding this important phase in research process. Thank you, sir, for your inspiring and encouraging words. A special thank to Reverend Father Joshi Chirangudi CMI, Principal of Christodoli College of Management and Technology, for providing immense support to make this webinar successful. I extend my gratitude to Dr. Anu Anthony, IQAC Coordinator, and Dr. Vineet Chandra KS, Secretary, Indian Accounting Association, Alapura, to organize this webinar effectively. I must thank the organizing team and volunteers for working hard for the past few days to make this webinar successful. I spread my gratitude towards all the participants for your active participation. Once again, thank you everyone.
Thank you, Mr. Kristen Matthew. We have come to the end of today's session. Let us meet the next day for yet another informative session. The feedback link is provided to you in the chat box, and for any queries related to the feedback link and the issue of the certificate, you are requested to contact the organizing secretary personally. And thank you all once again for your cooperation and support. Good night.
Okay, best wishes for your rest of the program. 3 more days.
Thank you.
Okay.
Yes, sir.
Okay.
Thank you so much, sir.
Oh, yes, thank you.
Thank you, sir.
Good night to all of you. Okay, we'll see on some other occasion also again. Okay, I leave.
Thank you.
Okay, right.